Last year, storms ravaged Britain once again. It's well understood how houses react to the wind, but the architectural flights of fancy of the last 30 years have presented engineers with a whole new set of problems.
It gradually became clear that it wasn't so much what the wind did to the buildings, but what the buildings did to the wind, and more importantly, what that wind did to the people. It's judged on the Beaufort scale, and this is Gale Force 8. And as you can see, I have to lean into the wind to be able to stand up. Okay guys, can you turn it down? Research has shown that the speed only needs to be above force 4, which is what it is now, just enough to ruffle my hair, for 20% of the time for it to affect people. Enough, for instance, to put them off using their local shopping centre. By testing buildings in wind tunnels, it means that bad designs can be thrown away before they ever get built.
Scale models can be tested in wind conditions just like the real location. In this, the building research establishment's latest wind tunnel. London's Docklands in miniature. Up there is the massive Canary Wharf Tower, and down here is a planned office, hotel and shopping complex. Now what the developers want to be sure of is that it's not going to be too windy along the promenade there and on the railway station. Tower blocks are known to cause a problem. Wind blows quicker higher up than it does near the ground, and tall buildings force that fast wind down to the street level. For the wind testing of the model to be realistic, the airflow must be just right. Docklands is surrounded by different terrain. There it is, with the tower blocks of the City of London to the northwest, housing to the northeast, and is practically surrounded by the water of the River Thames. This computer calculates how each landscape changes the wind speed at different heights. A clever new system reproduces those changes for the model. By turning these handles, you can raise or lower metal fins inside the tunnel. Wound high is like the wind blowing over tower blocks. Turned down a bit is like houses. And right down to the floor is like a stretch of water. With all 14 sets carefully adjusted, the wind matches real life for the model of the new shopping centre. After all this high technology, there's a strange return to nature. Ground walnut shells. They're sprinkled all over the model. And then it's just a matter of turning the giant fan back on. Where it's windiest, the powder blows away, like on the bridge. The model's rotated, and the fins are raised and lowered to test for different wind directions. A tiny probe is used to measure the wind speed accurately at the bare places, or at particular areas the designers are most concerned about. All that information is then combined with weather records to predict the wind speeds when the thing is built and say whether any design changes need to be made. But according to this first test of the building, and indeed of the tunnel itself, people won't be bowled over on the station, and they can stroll along the promenade and stop to admire the view in comfort.